In this lesson, let's learn about the microscope. From tiny cells to unseen microbes, microscopes open up a hidden world that the human eye alone could never see. But how did this tool come to be? To learn more, let's go back in time. The story of the microscope begins in the late 1500s. A Dutch spectacle maker, Hans Janssen, and his son, Zacharias, experimented with combining lenses. They created the first compound microscope. It wasn't perfect, but it was the start. Not long after, Galileo Galilei applied his skills with telescopes to improve microscopes. He added focusing mechanisms and lenses that produce clearer images. Then came Antonie van Leeuwenhoek in the 1600s. With his handcrafted microscopes, he saw what no one had ever seen before: tiny animalcules, what we now call microorganisms. Today's compound microscopes are far more advanced, but they all follow the same principle. Lenses bend light to magnify small objects. This time, let's identify the main parts of a compound microscope and their functions. First, the ocular lens, or eyepiece, is where you look through. It usually magnifies 10 times. Below it is the revolving nosepiece. With objective lenses, usually 4 times, 10 times, 40 times, and even 100 times. These work together with the eyepiece to magnify the specimen. The stage holds the slide. Clips keep it steady, while knobs allow precise movement to focus on specific areas. The diaphragm controls how much light passes through the specimen. The light source below provides illumination. Then the coarse adjustment knob moves the stage up and down quickly for general focus, while the fine adjustment knob fine-tunes the image. And finally, the arm and base. These parts provide support and stability. Always hold a microscope by the arm and base when carrying it. Speaking of handling, let's talk about care. How do we use and take care of the microscope? First, never carry it with one hand. Never tilt it. And avoid touching the lenses with your fingers. When cleaning the lens, use lens paper to avoid scratching the lens. And when storing, always lower the stage, switch the lowest objective, and place it gently in its cabinet. Have you ever used a microscope in school? What was the first thing you looked at? Share in the comments. We'd love to know. Now, let's try something exciting. We'll use the NC BioNetwork Virtual Microscope, an online tool that simulates a real compound microscope. This virtual microscope has the same parts as a real one: the eyepiece, objectives, stage, coarse and fine adjustment knobs, so it's perfect for practicing. Let's start with an onion root tip slide. Just like in real lab, we place the slide on the stage and secure it with the clips. We always begin at low power. Here, we are switching to the 4 times objective lens. Next, we use the coarse adjustment knob to bring the specimen roughly into view. Once we find the specimen, we increase magnification 10 times and then 40 times, just like we would on a real microscope. Now, we sharpen the image using the fine adjustment knob. Look at how the details become clear. Here, we can observe cell structures, the cell wall surrounding the cell, the cytoplasm inside, and even the nucleus. At higher magnification, these become more distinct. We will explore the cell organelles in the future, so please subscribe so that you will not miss it. So, what have we learned today? Remember that the microscope is an essential tool in science. It lets us see things too small for the naked eye, from plant cells to animal cells. We explored its main parts, like the eyepiece, objectives, stage, and focus knobs. We also learned how each part helps us view specimens clearly. We also practiced the proper way to use it. Always start on low power, use the coarse adjustment first, then fine-tune with the fine adjustment knob. And that's it for today. Thanks for watching. Like and subscribe for more videos coming soon. See you next time and stay curious.